You are freshers wanted to understand the cloud computing. You are from non-IT wanted to understand the cloud computing. For that matter, you are non-IT and you wanted to understand basics of the IT. Okay, and those who have that knowledge, please bear with me. So the first question is, cloud computing is an old chapter in a new book. Cloud computing is an old chapter in a new book because none of the cloud components we're going to talk about, whether it is a compute offering, a networking offering, a storage offering, a monitoring offering, backup, disaster recovery, load balancers, databases, DNS, access control, none of the concepts are groundbreaking innovations. When you talk about the compute options like servers, in AWS we call the servers as EC2, in Azure we call them as virtual machines, and in Google Cloud we call them as GCE, Google Compute Engine. In Oracle we call them as Oracle Virtual Machine. So terminology is different, but conceptually it is a server, virtual server. Okay, and in the compute you have the advanced options like Dockers and containers, which is an abstracted application environment, which we have it in traditional data centers. Okay, and when you step into the networking, we have the TCP/IP networking concepts like switches, routers, firewalls, load balancers, the true concepts as is implemented in the cloud, but that is like much simplified way. When you talk about the storage, we have got a block storage, file storage, backup storage, archival, backup as in archival storage, deep archival. Similar offerings are available in the cloud. For a block storage in AWS we call it as EBS. In Azure we call that as Azure Virtual Machine Disk Storage. In Google Cloud, yes, we call that as disk storage. And when you go to the load balancers, you have layer 4 load balancer, layer 7 load balancer, and DNS level load balancers, and they are same in all the cloud platforms. So guys, this is to build confidence in you. You may be working in different other areas as a DBA, as an Exchange administrator, as a SharePoint administrator, middleware, operating system, networking, storage, or even non-IT. Okay, don't think that you are new to the cloud, so you will not be able to understand the concept. Don't think that you are freshers to IT. You might be working in the other areas, but you are new to IT, so you couldn't understand the cloud concepts. Do not let that point to pull you back. Instead, know everybody upgrading their skills to the cloud today are working one or the other areas. For all of you, the cloud concepts are quite familiar. They are just finding a new way to deliver the services. That simple it is. So this is to set the stage and to clear your minds. Believe in yourself that you will be able to clear the certifications and interviews of any cloud platform that you choose, whether it is AWS, Azure, or Google. Because none of the cloud platforms are groundbreaking innovations, but they are built upon the traditional data center level concepts. That's it. Move on. A basic question, like I said, I'm going to ask you, what is an application? As a definition, application is a program written in one of the programming languages. It could be few lines, few hundreds or thousand lines of a code written in one of the programming languages to help us achieve a specific functionality. Let's say WhatsApp is a messaging application, but that's few lines of a code. Facebook, a social media application, few lines of a code. YouTube, a browser-based media player application, piece of code. Gmail, open source emailing functionality. It's a program, piece of code. So application is the very basic of IT. Whether you are a student or a doctor, police, a lawyer, or even an uneducated person in a society, today, as everybody holds a smartphone, you are consuming the IT services, you are using the applications. And there are thousands of categories into lakhs and lakhs of applications out there. There are thousands of categories, and into each category there are hundreds to thousands of applications, thousands to lakhs of applications. At the end, we consume these applications for different purposes. We've got a video editing software. We use that to modify your selfie videos a little bit and to publish them on social media, like TikTok on the other applications. You've got image editing softwares like Photoshop. You're gonna use it to modify your photographs. Communication tools like Gmail, charting tools, development tools to develop piece of code. So there are many applications, and we consume applications for different purposes to live our life in a better way. Okay, so consuming the applications is one side of a coin, that we're gonna use a particular application. For example, I use Gmail to send a mail to a friend of mine. That is not going to get me a job, but that will help me live my life in a better way using the technology. I can maybe send a message in WhatsApp. I know how to use a WhatsApp application. That's gonna help me live my life in a better way, but that will not get me a job. I'm gonna use YouTube, right? YouTube. I'm gonna watch a video. That will not get me a job. Watching a video on a YouTube will not get you a job, but that will help you live our lives in a better way. So that is a consumption model. What we have is, so consumption model will not help us get the jobs, but we need to explore the other side of a coin. What is the other side of a coin? YouTube. It's an innovative idea from Google organization. A video player on the browser that has got unlimited repository of videos, and we can compose our own videos and publish them either private or publicly, a length of your choice, a quality of your choice, content of your choice. It's an innovative idea. So they have designed it. They, as in Google, have designed it. They have developed it. They have hosted it, and they have been supporting it. We are consuming it. We are using it. Facebook. It's a wonderful idea, right? It's a great idea. It's an innovative idea. So they've designed it. They've hosted it. They've been supporting it, and we are consuming it. So in order to explore the other side of a coin, there are certain questions that we have to ask ourselves. Hey, what is needed to host an application? What is needed to host a YouTube application, a Gmail application, a Facebook application, and where to host that application, who and how it will be managed? Some of the questions, and you can ask the other questions like what programming language do you use to develop that application, blah blah blah. So I'm not getting into the development side of an application. We are speaking more into the infrastructure. So a basic question I have: what is needed to host an application? Per se, you've got MS Office application, right? To install MS Office, what you need? You need a compatible laptop, right? Or a personal computer. Since they are end user applications, you may use a personal computer. But if it is an enterprise class application, Venkat, can you differentiate between enterprise class application and end user application? Well, enterprise class applications are the applications that are used by many people 24 hours, 365 days. So to host such an application, the compute devices that is going to support that application must be highly available, highly scalable, redundant. So we're going to use servers. And end user applications are like your MS Office, your Google Chrome, the browser. So that is used by that particular person only. So if you wanted to use MS Office application, you will just open it, or else you just shut it down, shut your laptop down, your personal computer down, so it doesn't affect anybody else. Since it is a lightweight application, your personal devices like your laptops or computers or absolutely fine. But if you happen to bring enterprise class applications and install them on a personal computer, well, it cannot support the scalability requirements, because globally, how many people are using google.com? And do you think it is okay to host it on a laptop? The configuration of it is okay? Not actually. So what do you need to install an application is, you need an infrastructure. An infrastructure includes the following but not limited to. You're going to need a server. A server is a special purpose hardware designed to carry the heavy duty workloads. You're going to need a networking, because nothing is standalone today. Everything is internet connected. Since the time of big data, we are not talking about GBs or terabytes of data, but we are talking about petabytes, hexabytes. More than the capacity, we are talking about the response, the speed. We are expecting a millisecond latency or sub-millisecond latency response applications, sub-millisecond responsive applications. Per se, you go to a shop, you're going to make a UPI payment, you're going to use your Paytm or PhonePe or Google Pay. Just think, if it doesn't respond for half a second or for a second, we just don't like that behavior. So what do you think happens in the backend when you scan a QR code or when you enter a phone number into your UPI payment applications or your internet banking applications? All that happens within seconds, maybe less than a second of time, the transaction completes. How many components have been involved? So to provide such level of performance, it's not just about storage, it is about servers, it is about networking, it is about operating system, right? We humans cannot talk to the hardware directly. So you need somebody who can understand our machine language. For example, if you go to a processor, say, hey processor, what is 2 plus 2? Well, it cannot tell you because your language it cannot understand. Can you talk to a hard disk and say, please store this file, and when I wanted to read it, I'll open it? You cannot do that because hard disk cannot understand your language. That's where we need a proxy which understands the human language and understands the machine language. Take a request from you, execute that request on the hardware, gets you the results back. So that's the operating system, a proxy that takes a request from a user, executes it on the hardware and gets you the results back. A Windows or a Linux, because it is all about x86. We no longer live in a Spark generation. It is all x86, so only Windows and Linux operating systems we have. And of course, virtualization, because of many benefits that virtualization is providing to the business, to the IT administrators, it has become one of the mandatory components in every data center. Of course, in the cloud, no cloud can be built without virtualization. It could be a virtualization of a vendor choice. For example, if you talk about Microsoft Azure, I'm sure they must be using Hyper-V. And if you talk about AWS, they must be using ESX or ESXi. When you talk about Oracle Cloud, they must be using Oracle OVM. And you talk about Google Cloud, they must be using KVMs. Right? That is Red Hat Linux Virtualization Platform. And of course, where can you host your applications? At last, it could be cloud, that is AWS, Azure, VMware, Google, Oracle, anything it is. So we were talking about what is an application and what you need to install an application. Well, you need infrastructure to host an application. So that's where what infrastructure includes your cloud as well. Our biggest question that we can ask ourselves is what actually the cloud computing is. What actually the cloud computing is. Before we go there, I have one more question. The infrastructure components that we've talked about so far, where do you keep them? Where do you keep them? Whether it is a server or networking or storage, the other components, you put them into a data center. Okay, because let's say you've got, there is a building where your business operations are being performed. In a building, whether a particular room or the floor, based on the size of your IT infrastructure, you're going to dedicate that place, and that is called a data center. So a place where you're going to keep your IT equipment is called the data center. This is a basic definition, and we just have to remember it. That's all. Why do we call a bedroom as bedroom? Why do we call a kitchen as kitchen? Because that's how we arrange things and needed components in there. We have a gas cylinder or a gas connection. We have a stove. We have the water connections, a sink, a wash area attached together. So the facilities are arranged, and that's called a kitchen. Similarly, all the IT components put together into a room or into the whole floor, and that's called data center. And you're gonna have hygieneity maintained, air filters, maybe air temperature maintained like AC units. You're gonna have access control, whether it is ID card swapping or retina scan or biometric. It all depends on what kind of security standards are you following. But yes, data center is a place where you're gonna keep your IT components. That's called the data center. Where do we have these data centers? Where in the very beginning days of IT, maybe 70s, 80s, 60s, 70s, 80s, 90s, the only option that we all had, the whole industry had, was on-premises data centers. Meaning, let's say your TCS, you wanted to have IT for your services to deliver to customers. You're going to invest your money in buying or leasing the real estate space, and then you're going to invest your money in setting up all the data center facilities, because servers are like humans. If there is a corrosion air, the polluted air that is flowing through the servers, the components will fail. If the components on a server fails, your application is not available. Like google.com is not available. So if there are more frequent failures, like every day if you see google.com is not available, facebook.com is not available, we just love to find an alternative. And there are many people who is looking for a good business opportunity, and they will find it as a good opportunity. So to ensure that we have a great application continuity and there are no outages, you'll have to provide hygieneity. So provide facilities, right? And then invest your money in buying the servers. You remember, if you have to buy a laptop, maybe Microsoft Surface Pro, it is going to cost you 1.5 lakhs of rupees. Close to $2,000. And if you have to buy some 100 laptops because there are 100 employees in your organization, how much would it cost? 1.5 crores of rupees. Right? Then imagine how much would it cost to buy a server. On an average, 50 lakhs each server. And if you have to set up a data center of 100 servers, 5 crores just to buy the servers. And then you have to buy the support of the servers. On top of that, you're going to invest your money in buying the operating system licenses, then operating system support. And on top of that, you're going to invest your money for application licenses and application support, database licenses, database support. After all your investments, you're going to reinvest your money in hiring a server team, a network team, storage team, backup team, developers, QA, blah blah blah, all the teams. Then you're gonna hire their managers. Their managers may be senior manager, IT director, CIOs, CTOs. How much investment do you think all put together will be to set up an organization with IT services provided? It's gonna cost a huge bomb even to set up a data center of 100 servers. So in good old days, in the very beginning days of IT, that was the only option that we all had. You have to find a place that's most of the times in the same building where your business operations are performed. You're gonna find a room, place all your IT equipment, make other arrangements and facilities. That's the on-premises data centers. Over a period of time, companies whose core business is not IT, but they are into something else, let's say SBI, State Bank of India, they wanted to introduce IT to deliver their banking services to their customers in a better way, maybe internet banking, mobile banking, make UPI payments and all of that. So for them, the industry introduced a model called on-premises managed data centers because SBI wanted to introduce IT, but they do not have skill in it. They are very good in doing the banking, they are very good in doing accounts, but they don't know how to install, configure the servers. They do not know how to install, configure, manage databases and the other IT services. Now they need some help. That's when they call for a bidding. Service-based companies like TCS, Wipro, Infosys, IBM, HP, CSE, and all other companies are going to bid for it, saying, hey, we have a team of 20 people, wonderful, well-trained, well-certified, have good experience. And the other company says, we also have similar team. Moreover, we have a previous experience that we have implemented a similar project for Andhra Bank, for ICICI Bank, for HSBC Bank. The other company says, we also have implemented similar offerings for global banking organizations, for global banking companies, global financial institutions. So it is up to SBI to consider, let's say, per se, that TCS got an offer. I mean, TCS got that project. So SBI is to invest all their money in either buying or leasing data center facilities, buying the other IT infrastructure components, and they also they also pay to TCS for providing the services. Now TCS, either they sit in TCS premises or they come to SBI premises. It all depends on the contract terms. Either they provide remote support or on-premises support, but they're going to support it either for 5 years or 10 years. It all again terms of the contract, but that is on-premises. So 75-80% of the IT employment that we have today, that is in the managed data center services. You may be into holiday management, you are a hospital organization, you are an educational institution, you are a manufacturing industry. Today you see there is no industry without IT involved. There was a time we had a discussion, rather a debate, that IT cannot exist without a business and business cannot exist without IT, and always business wins because IT is not mandatory for a business, but for IT, business is mandatory because they have to pay. But today it is one-sided answer and you just cannot imagine any business without IT. That's how things have changed. And finally, where can you have the data center? That's in the cloud. Okay, you put all the IT infrastructure into a place that's called on-premises. You also have an option called on-premises managed data centers. And of course, now you can have the data centers in the cloud as well. And this is the biggest question that is triggered today. What is the cloud? What is the cloud? You talk to a DBA, he says hosting Databases in a remote location is called the cloud. You talk to a developer, his definition is developing applications remotely, connecting to some other data center is called cloud. You talk to a backup engineer, his definition is backing up the data to a remote location which is not managed by us is called the cloud. So what actually the cloud is? Well, the cloud computing is all about, I think I've mentioned this already, for you to set up a data center, you're gonna need a real estate space, and then the facilities, hygienity. On top of that, the servers, networking, storage, load balancers, firewalls. On top of that, you've got a software layer. On top of that, you've got a management layer. This is all going to be a capital expenditure. We're going to invest the money upfront and then you're going to hire your IT teams to support IT, to develop applications, which is accumulating to a huge money, a lot of money. Even to set up a small data center, you have to invest a lot of money. That's one of the reasons until few years back we do not have a concept of startup companies, because if you need maybe a data center of 10 servers, you definitely have to invest close to 10 crore rupees, a minimum. So 10 crores only for IT, then you have the other departments of the organization. It could be marketing department, it could be HR, finance, your actual engineering department, whatever the scale of business you are into or the industry that you are into. Your seating capacity, your other facilities, it is gonna sum up huge money. And let's say your idea is wonderful, you invested all your money. Unfortunately, society did not receive the concept very well, and you stand the failed business. You know how much it is going to cost you? And that's the reason we did not have startup companies culture until 2009-10. But with the introduction of the cloud computing, you see a lot of startup companies comes out, a lot of business opportunities, a lot of employment, is because big companies like Google, Amazon, Microsoft, Alibaba, Oracle says, there are 50 other providers says, hey buddy, you need a data center, why do you invest huge amount of money? Instead, we've already built the data center for you. We've already built the data center for you in possible number of physical locations. Because today it is global business, not confined to a particular area, not specific to a particular area, but almost for every business we have the global customers. To reach your global customers, we have set up the data centers, a physical data center in possible number of locations, maybe let's say 60 locations in the globe, and we have plans to increase that to 100, 200, 500 as days, weeks, months and years pass. And we've ensured there are close to 200 services available. I'm not talking about any particular cloud provider, but overall, more or less, close to 200 services we have into compute, into networking, into storage, monitoring, access control, databases, machine learning, artificial intelligence. So, you being a customer, all you have to do is connect to our data centers over the internet and make use of any individual services or any combination of services. At the end of the month, you only pay for what you actually use. Let's say you have used servers for 20 hours in the whole month and you only pay for 20 hours. See how wonderful it is. We always dream of driving a premium race category Ferrari car, let's say, which costs some 10 crores of rupees. And if somebody says, hey, I'll give you that without you spending 10 crores of rupees, just pay me 100 rupees and you can drive it for 1 hour. And after 1 hour, that's all, you just give it back. And you don't want to drive it for 1 hour, maybe you just use it for 30 minutes and you just pay 50 rupees. So no commitment, it is based on your usage. The lease model. I think there are many apps as such into the cars, into the bikes. They say you do not have to invest your money in buying the cars, but you can rent the cars. Pay as you go. It's a similar model. You can use any individual services from 200, the list, or any group of services, and you only pay for what you actually use. Not more, not less, no commitment. You do not have to commit. You will use the services for 2 years or 3 years or 5 years, but it is absolutely based on your usage. I may have 10 fans. I may have 10 fans and you just have 2 fans. I may have 5 air conditioners, AC units in my house and you just have got 1. At the end of the month, maybe lights. I may have 20 lights in my house and you just have got 2 lights in your house. At the end of the month, your bill could be 2,000 rupees and my bill is just a minimum, let's say 500 rupees. You can't ask why, because it is not always about the number of electronic devices you have at your house, but it also depends on your usage. How many hours a day that you are using AC, how many hours a day that you are putting the fan on and the lights. So it is not that how many services are you using, but it is about your usage. So they're gonna measure your usage, and based on your usage, they're just gonna bill you. That simple it is. So cloud computing is about big organizations like Google, Amazon, Microsoft delivering the IT over the internet to the customers. Okay, what they are doing here, instead of a customer investing all his money, these big companies have invested their money, set up the data center, and they are delivering the data center services over the internet to the customers. There are close to 200 services.